Hi everyone. Today you will start the unit on finding areas of polygons and circles. The first thing we're going to look at is areas of parallelograms and of triangles. Okay, so let's remember that a parallelogram was a quadrilateral with both pairs of opposite sides parallel. In the case of a parallelogram, any of the sides can be called a base. Now, the length of the altitude is called the height of the parallelogram. So you have your base and your height. So any of the sides are the base, and the altitude is called the height. Now what you have to absolutely remember is that the altitude must always be perpendicular to the base. Okay. You will see here that the area of a parallelogram, which includes rectangles, squares, and rhombi, is base times height. So you have the base and the height, which must be perpendicular to the base, and that is equal to the area. All right, so let's take our very first example. Now, in this case, we have that this side is 18 and this side is 12. Now, this line is drawn perpendicular to one of the sides. That's what you're going to focus on. This, if this is perpendicular to the side WV, then we're going to call this our base, and this will be the height. Okay? Now, if we know that this is 18, then we know that this is 18, so my base is equal to 18. What I don't know is how big the height is, but luckily I'm given an angle, which is 60 degrees, which should remind you of special triangles. Let's just remember what special triangles looked like. If you have a 30, 60, 90 triangle, the smallest side is x, the next one is x root 3, and the hypotenuse is equal to 2x. Or if you had a 45, 45, 90, then both legs are x's, and this hypotenuse is x root 2. All right, so let's use that. In this case, we have a 30, 60, 90, okay? The hypotenuse is 12. That means the small side, which is this, is x, because the hypotenuse is twice this, so this is x, which also means that the height is 6 root 3. Okay, so we have a 6 root 3, and a 12. Now, we can find our area. Remember that area is equal to base times height, so that's 18 inches times 6 root 3 inches. That means my area is 108 root 3 inches squared. Okay, remember, area gets units of inches squared. We also have to find the perimeter of this. The perimeter of TRVW is all the sides added together. And notice, if it's a parallelogram, opposite sides are equal to each other. So we have 2 of the 12-inch sides, and we have 2 of the 18-inch sides. So finally, the perimeter is 60 inches. Okay, let's move on to this next one. We need to find the perimeter and the area of this parallelogram. All right, we're given that this is 29.6 and 33.3. We need the height. Now, in this case, what I have is a 45, 45, 90. That means this and this are both x, and this is x root 2. So if x root 2 is equal to 29.6, then if you divide both sides by root 2, x is equal to 29.6 divided by root 2. So x is equal to 14.8 root 2. Okay? This is my height. H is equal to 14.8 root 2. Okay, we can use that now to find the height, because area is base times height. So area is 14.8 root 2 times the base. If this is perpendicular to side AB, then that's the one that you take as your base, and the length of that is 33.3. So at the end of the day, area here is equal to 696.98. And the units are centimeters, so area is centimeter squared. Okay. Perimeter is 2 times 29.6 plus 2 times 33.3. Perimeter is 125.8 centimeters. Okay. Let's move on to areas of a triangle. The formula for the area of a triangle is base times height over 2, or I actually prefer half times base times height. Okay? B is the base, H is the height. Again, it must be perpendicular to the base, always. All right, so in this case, let's find the area of each of these triangles. I'm not given the length of the height here, so I need to find it myself. I am given an angle, that means I need to use trigonometry to find the height here. Now, what I'm given is, if I just focus on this triangle, this is the hypotenuse, and it's 4. I don't know how big this side is, because 5 is for the entire length here. So I don't know how much this is. I need to find H. What I have here is the hypotenuse, and the opposite side, that's a sine ratio. So I say sine of 37 is equal to H over 4. That means H is equal to 4 sine 37. H is equal to 2.4. 1 decimal place is enough if you're finding length of a side. Let's find area. Area is equal to half times base times height, which is equal to half. Now, the base is this entire thing here, 5. Remember, that's the side that's perpendicular to the altitude, times the height is 2.4. And if you plug that into your calculator, then all this is equal to 6 centimeters squared. All right, this is the next one here. We're given that this side is 29, and there is a right angle here. We need to find this side. This is the height, okay? We know that this is 6, and this side is 13. To find the height, we're not given any angles here. We have to use the Pythagorean theorem. So 6 squared plus h squared is equal to 13 squared. And h is equal to root 133, which is about 11.5. All right, the area then is half times base times height. That's half. The base is 29. The height is 11.5. So the area is this centimeters squared. It's actually 166.75. All right, next. Here's a postulate. It's common sense to most of you, but it's a postulate nonetheless. The area of a region is the sum of all the areas of its non-overlapping parts. So if you take a look at this, you can split up a shape into several parts, find the area of each of the small parts, add them all together, then you have the shape, then you have the area of your shape. Most of the time, the shapes that you're going to find the areas of are not regular polygons. A lot of times they're just irregular shapes. So you split them up into shapes that you know the areas of. You split it up into squares, you split it up into parallelograms, into rectangles, into triangles, okay? All right, so in this case here, you've got all sorts of stuff happening, but focus on the big picture. What you have here is a triangle, and you have another triangle there. So if we just focus on triangle ABD. And let's find the area of triangle ABD. This is the height because it goes from the vertex perpendicular to the opposite side, and this is the base. So the area of triangle ABD is equal to half times the base times the height. Half times 10 is 5. So this is 5 times 13, meaning the area of triangle ABD is equal to 65. Okay. Similarly, we want to find the area of triangle DBC. Okay. So area of triangle DBC is equal to half times its base, which is 17, times its height, which is 8.5. The area here is equal to 72.25. Now the total area is the area of these two, 65 plus 72.25. So the total area of the figure is 137.25 centimeters squared. All right, for this next one, again, we have two triangles. Here's my first triangle. Now, it tells you that FH is equal to 37. So this is 37. Now, that's your base, and this is your height. Okay, so that's the base, and this is the height. The total area here is going to be the area of both of these together. So it's this is equal to the area of this triangle is 37 times 18 divided by 2 plus the area of this triangle is 37 times 9 divided by 2. I want to get you used to both forms of the notation. The total area here, when you plug it in your calculator, is 499.5 squared inches. All right. Most of the time, you're going to be given the area, and you need to find the different values. So in this case, we're looking for x. X is the height. You always start with the formula. This is a parallelogram, so the formula is area is equal to base times height, and you substitute everything that you have. So in this case, we have that the area is 153 inches squared is equal to the base times the height. You divide both sides by 9 inches. Notice one of the inches cancels with the other inches. The units must match, right? So x is equal to 17 inches. In this case, we have a triangle, okay? And we need to find x, which is, again, the height. The area of a triangle is equal to half times base times height. Now, this is the height of the triangle, and this is the base of the triangle. Well, if the whole thing is 41 minus 11, this is 30 centimeters. That means the area, which is 165, is equal to half times 30 times x. 165 is equal to 15x. You divide by 15, and x is equal to 11 centimeters. Okay, one more time, one more. The base of a triangle is twice its height. If the area is 49 square feet, find the base and the height. We draw a triangle with the base and the height perpendicular. Now the base is twice the height. So if this is x, then this is 2x. And the area is 49 square feet. Again, we start with the formula. Area is half times base times height. 49 is equal to half times base times height. What does that mean? That means that 49 is equal to, the 2's cancel, x squared, so x is equal to 7. Okay? Therefore, if the height is equal to 7, then the base is 14 feet and feet. Okay. Heron's formula. Usually we learn this with the law of sines and cosines, but it's in this chapter for this book. Heron's formula relates the sides of a triangle to the area of the triangle. Now, this is the formula. So it's S minus A, S minus B, S minus C. S is what we call the semi-perimeter, which is equal to 1/2 the perimeter of a triangle. So basically, if you have a triangle, A, B, C, the perimeter of this triangle, you know, is A plus B plus C. Now, if you took that perimeter, A plus B plus C, and you divide it by 2, because we like doing that, because it's fun, that would be half of the perimeter. We call it the semi-perimeter, and we label it as S. So if you took the semi-perimeter and you subtracted the first side and the second side and the third side, and you put it all in the square root, you get the area of a triangle. So let's try and do this one. Use Heron's formula to find the area of a triangle of lengths 5, 7, and 9. So here, this is 5, this is 7, and this is 9. What we have to do first is find S. And S is just all the sides added together divided by 2. 5 plus 7 plus 9 over 2. S is equal to 10.5. Now, what you need to do for the formula now is area is equal to the square root of S, 10.5, times S minus the first side. So 10.5 minus 5, then 10.5 minus the second side, and 10.5 minus the third side. Now, I'm writing this out the first time, but if you can do it in your mind, then it's totally fine. So area is equal to the square root of 10.5 times 5.5 times 3.5 times 1.5. And finally, this is the square root of 303.1875. Of course, if you can plug it into the calculator in one shot, I like that. This is 17.4, and it would be units squared. Okay. Now, here, we have to show that this is true. So show that the areas found for a 3, 4, 5 right triangle are the same using Heron's formula and using area equals half base times height. All right, so here is a 3, 4, 5 triangle. You know that that's a right triangle. Now, using Heron's formula, S is equal to 5 plus 4 plus 3 over 2, so S is equal to 6. And if you put it in the area formula, then what you get is 6 times 6 minus 5 is 1, 6 minus 4 is 2, 6 minus 3 is 3. So area is equal to the square root of 36, which is equal to 6. All right, now let's do it using our formula, half times base times height. Well, if you have two sides that are perpendicular, then one is naturally the base and the other is the height. So this is equal to half times 3 times 4, and magically, that's equal to 6. They're both equal to each other, so we're good. All right, so this homework will be due next week, Monday. Oh no, this homework will be due Tuesday. Have a good weekend, everyone.